let us discuss important points while designing schema. Here, we will create schema definition files for the 4 tables described earlier and use the schema loader to create those tables in ScalarDB. As discussed earlier, we will create point history table in Cassandra and the other 3 tables, point summary, point pending, and point active in MySQL. ScalarDB has its own data model and schema. When we use ScalarDB's transaction manager, it not only stores user-defined data but also metadata such as transaction IDs, record versions, and transaction statuses. The ScalarDB schema loader is a CLI tool that creates a ScalarDB-specific schema from the definition file. To run the schema loader, specify the schema loader jar file as a Java argument, then the properties file you have created earlier, and finally, the schema definition file. When you run the schema loader for the first time, use coordinator option. This option creates the coordinator table managed by the ScalarDB system. Now, let's take a look at the structure of the schema definition file by taking the point history table as an example. The table definition shown in a general tabular format is shown on the left, and the corresponding schema definition file is shown on the right. The table definition in tabular format includes the column names, data types, partition keys, clustering keys, secondary indexes, and sorting attribute to be set for the clustering key. Let us discuss how the schema is defined for a particular table. First, specify the target table. This is specified in the format namespace, .tablename. The transaction field indicates whether the table is for transactions. If you set the transaction field to true, the tool will create a table with transaction metadata. If you set the transaction field to false, the tool will create a table without transaction metadata. Tables with the transaction field set to false are operated using a different API, called the storage API. We will cover the storage API in a different course, so for now we will set the transaction field to true for all tables under consideration. Specify the column to be used as the partition key. Here, user ID is used as the partition key. Next, specify the clustering key. In this table, issued datetime is the clustering key. For the clustering key, the data rows are sorted and stored based on the key value. Specify the sort order as ascending or descending. Next, specify the data type for each column. In this table, the transaction ID is specified as a secondary index so that the relevant records can be retrieved using the transaction ID. This completes the schema definition for point history. Similarly, here is the schema definition for the point summary table. This is the schema definition for the point active table. This is the schema definition for the point pending table. In the example, we created separate schema definition files, but it is also possible to combine them into one file. Now, let us run schema loader on point history. Since this is the first time we are running it in this environment, we will run it with the coordinator option. Let us see how to create a schema for the point history table on the Linux console. Open Linux terminal. Execute the specified command to load schema. Execute command docker ps to get running containers. Execute command docker exec-it container id to open Cassandra container. Execute cqlsh command to open command line interface. Execute command describe key spaces to display the ns_Cassandra namespace. Execute specified command to display the ns_Cassandra namespace. Now, execute specified command to display the point history table.